guys, I hope you all had a really great day. I'm here to just quickly go through the notes that we discussed. I know that all classes did not finish these notes, either on Wednesday or Thursday, but I'm going to go ahead and do the entire video just so it's done, so that if you're looking at it either tonight or Friday night or over the weekend or whatever, we have the whole video here. So we were talking about measuring and constructing angles. And so we talked about how to name an angle first and foremost. So first we have to know what an angle is. So an angle is a set of points consisting of two different rays that have the same endpoint called our vertex. So in the picture here below that I have, you're going to have 3 points. I'm sorry, I didn't mean to write a C there. Silly me. You're going to have 3 points on that angle. And those points are all going to be on rays as well. So BA, that's a ray. BC, that's a ray. And together they form an angle. So they intersect right here at B, and that is called our vertex. And then the 2 rays that make up the other part of the angle, those are called your sides. So the rays are the sides of our angle. So we kind of have an option to name our angle multiple ways. So the first way we can name it is just by using the vertex. So we can call that angle B, just be done. You don't have to do anything else. You can also use a point on each ray and the vertex. So this would be angle ABC, or you could call it angle CBA. But you have to make sure that when you're naming them, that the vertex is the middle letter. So you cannot call this BCA. You cannot call it angle BCA, because then that would imply that C was the vertex there, okay? And the last thing, if they include a letter, which does not happen very often, but if there's a letter, like I added that little 1, we can call this angle 1, okay? Now, we do have to be careful on that first one. I always say there's kind of like a little asterisk on it, okay? And there's a stipulation, and that stipulation comes in. Oops, sorry. Oh, I wish that would stop. Okay, hang on. So, like, if this is my angle, and I call this A, and this is B, and this is C, and then now this is D. So in this picture, we actually have 3 different angles. We have this angle here, ABC. We have this angle here, CBD. And we have this big giant angle, ABD. So on that first one where it says you can just use the vertex, we can't just call it angle B here, because which angle are we talking about? This angle, or this angle? We don't know if it's 1, 2, or 3 by just saying angle B. So if a vertex is shared by multiple angles, then you can't name by vertex only. Okay, so make sure you know that. All right, so we have our first example, and it says a lighthouse keeper measures the angles formed by the lighthouse at point M. So there's the lighthouse right here. And then we have these 3 boats out here, J, K, and L. And it says name the 3 angles shown on the diagram. So you could go from J to M and then end there at K. If you're talking about that angle, you could call that angle JMK, or you could call it angle KMJ. You have to make sure M is the middle letter, and you can't just call it angle M, because angle M is used for multiple angles. So the next angle we're going to talk about is this one here, KML. So again, KML, or we could call it LMK. K. But you can't call it angle M, and you have to make sure M is in the middle. And then we have the big angle. That was a weird way to say big, I'm really sorry. And that's angle JML or angle LMJ. Be careful when you're drawing your angle measurements. Make sure they don't look too L-ish. Okay, so we also talked in class about classifying angles. And we talked about acute angles being less than 90, obtuse angles were greater than 90, and right angles were equal to 90. This part right here, this between 0 and 90 part, that just means that like acute angles can't be negative, so they can't be less than 0. And obtuse angles can't get bigger than 180. So they're anywhere between 90 and 180. The new one that I'm sure most of you haven't heard of is the straight angle. And a straight angle is just literally a line, and they measure a full 180 degrees. So it says find the measure of each angle and then classify each angle. So our first example is we're going to do G, H, K. Okay, and if I zoom in on our protractor here for G, H, K, since G starts over here at what you always want to measure from 0, so we're going to go on the top numbers and work our way this direction until we hit the other side over here. So it hits that side at 125 degrees. So angle GHK is 125 degrees. We also talked about in class that if you know the measurement, so if I know what GHK measures, you have to make sure you put that M out front. M means measure. So our second example is JHL. So here's J, here's H, that's L. So J starts over here. We're going to go up this direction, and so this is 90 degrees. It also asks you to classify these, so this one would have been obtuse, and then that makes this one right. Okay? And then our last example is LHK. And this one's kind of tricky, actually. Measure of LHK. So here's L, here's H, and here's K. So it's like this little wedge, and it's hard because it doesn't start at 0. But what we do know is that L starts here at 90, and if we go along the top numbers, K ends up being at 125. So you can take 125 minus 90, and that gives you 35 degrees, and that's how much that measures. Okay, so we also talked about congruent angles. So two angles are congruent when they have the same measure. So if these are two angles I gave you, angle 1 and angle 2, I'm actually going to not call them angle 1 and angle 2. Sorry. I'm going to call this A and this B. Okay. Angle 1 here is right there. Angle 2 is right there. All right. And I'm sorry. I just told you I wasn't naming them 1 and 2. I don't know what I was doing. So you have A and B. If I know that they're the same measure, I'm going to mark them with this little, gosh, what did I call it? Like a curve. And then since they're marked with the same curve, that means they're congruent. It's kind of like the tick marks that we used for segments. That's kind of the same thing. If I have those markings, I can say that angle A is congruent to angle B. If I know that angle A is 30, and I know angle B is 30, so then they're equal, I can say the measure of angle A is equal to the measure of angle B. So when we do measurements, we drop the congruent symbol. So then we did this little quilt design, and if you notice here, like up here at G and down here at B, they have the same markings, but over here at F and D, they have a different set of markings. That's because G and B are congruent to each other, and D and F are congruent to each other, but like B and F are not congruent, okay? So that's why they use two different markings. So it says if ADC, so this angle right here is 140, then what is EFG? Well, those are both marked the same, so I can say that EFG, that measurement, is equal to 140 degrees. So we talked about the angle addition postulate being kind of like the segment addition postulate, where you take a little piece and a little piece, and they should add together to make the big piece. If I take this piece of the arc of the angle plus this piece of the angle, they should add together to give me the entire angle. So if I know this side's 20 and this side's 30, I can add that together to get 50 for the entire angle. So we're given that the measure of LKN is 145. So L to K to N, that's that entire angle being 145 degrees. Okay? So if I take what I know from the angle addition postulate is I can take that 2x plus 10, add the 4x minus 3 piece, and it should all add up to 145 degrees. So 2x plus 4x is 6x. 10 minus 3 is 7. And that adds to 145. Subtract your 7 over, so 6x equals 138. And then I believe x equals like 23, but I could be wrong. So I'm going to do that on my phone really quickly. Oops, cancel. Yeah, and that shouldn't say 6x. That should just be x. So x equals 23. So all that did was find x, though. It didn't find anything else. So if I want the measure of LKM, which is this side, I take that 23 and I plug it in for x. So 2 times x plus 10 is 46 plus 10, which is 56. So the measure of LKM is 56. So I have one more piece I have to do. I have to find MKN. So if I know the whole thing is 145, I can take the whole thing, 145, minus the piece I just found out, and find that that last piece is 89 degrees. So this side's 89. Okay, bisecting. We did not talk about this in class today. However, we will talk about it in class tomorrow. So bisecting angles. An angle bisector. So we know that bisect means to cut something in two, just like we had a segment bisector. Now we're talking about angle bisectors. So an angle bisector is a ray. So this is our ray. And it's dividing this big angle into two congruent pieces. Okay? So if I know this whole angle is 50 degrees, if this is an angle bisector, then this side is 25 and this side is 25. So here they don't draw me a picture, and I'm a very visual person, so I'm going to kind of draw myself a picture. And I don't really know what PQR looks like, but I'm just going to do my best. So I know it's called PQR, so that has to be P. Q has to be in the middle, and this could be S over here. P and S you could have reversed, but Q has to be the vertex. And it says that Q, I'm sorry. I'm really sorry. I'm wrong. So I know Q is the vertex. I have the angle PQR. So this is P and this is R. S is on the ray. So this is QS. That's the ray that bisects it. So it says that PQS, this side is 24. So I need to find PQR, and that's the entire angle. So if I want the measure of PQR, if I know this is getting cut in half, if that side is 24, then that side is also 24. So 24 times 2 is 48. So that's really, you just had one more example left. Your homework is page 43. We're going to do 3 through 12, 17 through 20, 21 through 29 odd, and 33 through 39 odd. So good luck. If you have any questions, please let me know, and I hope you all have a really great evening.